Here's the definition of a common logarithm. Please feel free to take a picture if you wish. Bottom line, long story short, and the button on your calculator, that when you see the log without the little base, it's just understood that it is base 10. Okay? So for example, up here, you see it's written like this with the little 10. It's written like this with the little 10. If you see just a log, like the button on your calculator, it means log base 10. That is known as the common logarithm. And as you can see here, this sentence, you usually don't write it. You don't write the base. Okay? So just know when you see a log by itself without a base, or if you're wondering about the button on your calculator that just says log, it means log base 10. And that is the common log. Okay? And basically, what I wrote there. The log button on your calculator means log base 10. We just don't write the 10, because it's so common in the number system that we live in. All the properties that we learned yesterday, all the exponential form and logarithmic, it all still applies. Okay. It all still applies. Questions on any of that? Alright, let's test it out. Here are two examples. Use your calculator, round to the nearest 10,000th, so 4 places. Use your calculator to figure out what log 7 is and log 1/2 is. Just do that on the calculator, round it to the nearest 4 places. So here's what you should have got. Now, let's try and interpret what this means. Okay? Since 7, 10 to some power, it's not going to be nice. It's going to equal 7. 10 to some power is not going to be 1/2. So what this means is that giant number that you got in your calculator that never ends means that's the power that you have to raise 10 to in order to make it a 7. So 10 to the this power will give me 7. 10 to the this power will give me 1/2. And if you typed it back in now and used these numbers as your powers, it wouldn't be exactly 7 and it wouldn't be exactly 0.5 because these are estimates, right? The only way to get it to actually equal 7 is if you can store that number in your calculator with all the digits that never end and raise it to and take that as the power, 10 to that power. And that's how you would get it to 7. So one of the reasons why this is useful is because all the problems that we've really worked on, except for yesterday, got a little bit tricky. But for the most part, the powers turned out nice, the numbers turned out nice. We could get the bases to be the same. We had to think about it, like we had to raise 3 to some power and both sides or whatever in order to make the bases the same. But sometimes the bases aren't going to be the same, and you're not going to be able to get them to be the same, which is one of the reasons why logarithms are so important. Logarithms allow us to solve exponential equations that aren't nice. Okay? And we're going to look at some of those today. So, this is we've been building up to this point where we can actually do something with logarithms. So we spent time practicing properties of logarithms and going from logarithmic form to exponential form and vice versa. The real deal here is logarithms allow us to solve exponential equations that aren't pretty. And we've been just dealing with sort of quote-unquote pretty equations for now. Now they're not going to be so pretty. And we're going to have to take those properties that we learned yesterday. We're going to have to take our understanding of exponential form and logarithmic form, smash it all together in order to solve an exponential equation. Like this. See, I can't turn 15 into 3 to some power. Because that's what we would do before. And I would advise you to try to do that whenever you have an exponential equation. Can I change them so that they both have the same base? Because you know now that if we did that, we just set the powers equal to each other and we're good to go. Right? There's no way to raise 15 to a power or to change 15 so that you can raise it to a power with the base 3, right? Because it's 2, it's 9, 3 is 3 to the third is 27. So I can't get it there. So what we do is we take the log of both sides, which you can do. Whenever you have an equation, you can take the log of both sides. Okay? And notice I didn't write the base. Because when we don't write the base, it's just understood that the base is 10. Okay? So here's what this is going to do for us. Because of our power properties, what happens with this x? It goes out in front. Okay, like that. So now we can take our power property. So we're one step away from getting the x by itself and being able to solve this exponential equation. Because what do I need to do now? How do I get the x by itself? Say it louder.
Divide by log 3.
Divide by log 3. So I've got x times log 3. All I need to do is get rid of this log 3. So I can just divide both sides by log 3. So now we're set up to solve this. So plug that in your calculator and see what you get. Log 15 divided by log 3. Do that. And don't estimate until the end. So use your calculator and let your calculator use all the digits of log 15 and all the digits of log 3 and then round. Don't round this and then round this. Plug this in your calculator and round at the end. So here's what you should have got. How many got that? Okay, so let's understand what that means. Okay, 3, because the original problem, was 3 to the x equals 15. So that means if I take 3, and let's think about this too. 3 squared is 9. 3 to the third is 27. So we would expect that x would be between 2 and 3, which it is. Okay, so if I take 3 to the 2.46, I think it was 497 something 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 power, then that will equal 15. Okay. This is an approximation. This gets us close. Whenever we're dealing with logarithms, we round to 4 places. Okay. Any questions on that? Okay, you do that one. Like, how many of you thought of an answer right away when you saw this? You're like, oh, it's 7. Anybody? Right. I gave you those numbers on purpose. Because you see that 42 and the 6, and you know that 6 times 7 is 42, but it's 6 to a power. This is the same kind of problem as we just did, so go ahead and do that one. What should we expect this power to be between? If I had to pick a couple integers, what should x actually be in between here?
1, 2, 3.
Why 2 and 3?
Because x squared is 36.
6 squared is 36?
Yeah.
And then 6 to the third is 216. So what I expect this to be between 2 and 3, okay? Now since 6 squared is 36, it's probably going to be really close to 2, because 42 is not that far away from 36. So as you enter into a problem like that, you should have kind of a ballpark idea of what kind of number you should be looking for so you can check the reasonability of your answer. Okay? Log of both sides, you're good to go. How many had that? Okay, good. Now, I want to talk about something else for a second. I saw a couple people do this with the exponential, and they wrote it the original problem like that. Because 6 to the x equals 42, that's what this really means. Okay? The problem is, well, it's not really a problem because your calculators are so sophisticated now, you can change base really easily. But because the log button is log base 10, and I'm not going to show you how to use that on your calculator. Some of you have already figured it out. But ultimately, back in the day, when you only had the little TI-30X, okay, you had to know how to convert this using log base 10. And I'm going to show you how to do that. And you're going to have to know how to do that even though your calculator will do this for you. You're going to have to know how to convert this into log base 10, which essentially will turn it into this problem. Okay? At this problem here, after I rewrote this, notice here, this is what we did before we even saw this. Okay, so I changed the base log 42 over log 6. That worked the same way when we solved it using log of both sides. So, this is known as the change of base formula. Again, if you want to take a picture of that, feel free. If you notice here, based off of the end of that last example that I showed you, basically what you can do is when you have a base other than 10, you can just basically put it as log n over log a. Okay. So here, for example, and I wish they wouldn't have written the 10 in, it's not necessary. Log 11 over log 3. So when you want to change base, if you want to get them all into standard common logs, all you've got to do is on the numerator, take the bigger number, and on the denominator, take the base. And if we look back, the change of base formula allows us to do. You're going to have some problems that are going to require you to change the base. And you're going to have to turn it into problems like this. So, here's one. I wrote that 3 in there because the 3 was so small I thought you wouldn't be able to see it. So go ahead and write log base 3 of 20 in common logs. Like this example right here. And then figure out what it is. And then take a look at the screen to make sure that that's what you got.